Welcome to this lecture on AI in HR decisions, fairness, explainability, and privacy for digital HR transformation. If you recall, in 2019, Amazon publicly disclosed that they had discontinued their AI recruiting tool. The reason was simple, yet alarming. The algorithm had systematically learned to discriminate against women. It downgraded resume containing the word women and favored male candidates. This was not a malfunction. It was the system working exactly as designed, learning from biased historical data and replicating it at scale. Today, we find that more than 25% of organizations worldwide are using artificial intelligence somewhere in their HR decision-making processes. These systems influence recruitment and selection, performance evaluation, promotion, and compensation decisions. They're also looking at the learning opportunities and retention management. They affect millions of careers and billions of the dollars in compensation, and they are reshaping the future of work itself, a great cause of worry to the present practitioners and the present generation. In the light of this lecture is designed to see that how AI, to what extent AI should be used in HR decision making. I'm R.K. Singh, and we will explore three essential questions every HR professional and the data scientist must answer. That is, how do we ensure that algorithm decisions are fair across different groups? How do we explain AI-driven decisions to employees, to regulators, and to the court? And how do we protect employee privacy while still using data responsibly? And I'm sure that by end of this lecture, you will understand the academic foundations of ethical AI in HR, the global and Indian regulatory landscape, and the practical framework that looks at the governance of AI. Let me begin with the AI, which is revolving around HR. According to the Deloitte's 2024 Global Human Capital Trends Report, artificial intelligence has moved from experimental to fully operational across HR functions. Automated resume scanning, predictive turnover modeling, performance prediction, and compensation recommendations are now mainstream. Organizations report 70 to 80% reduction in time to hire 50 to 60% people. It has decreased the administrative work of human resource department. The predictive accuracy has increased and ranging between 80 to 90% in terms of the turnover prediction. But the same systems that bring efficiency have exposed fundamental ethical problems. As you know, Amazon's algorithm penalized resume from women because the training data reflected male dominated hiring. In the same year 2019, Hairbu's facial analysis tools raised concerns about disability discrimination. In 2019, a healthcare algorithm in the United States underestimated the needs of black patients. See what AI is doing. In 2021, the work today faced legal action for alleged racial and age discrimination in algorithmic filtering. And similarly, you can find out numerous examples to see that what kind of the issues are cropping in when we are using AI, particularly in HR decision making. So maybe in other domains. These are not isolated incidents. They represent what researchers call the discrimination feedback loop. The historical data reflects biased decisions. The algorithm it learns those patterns and predicts accordingly. So data is fed, it is analyzed, churned, and the machine is behaving accordingly. Those predictions influence future decisions, reinforcing the same bias. So if I'm allowed, I can say that in short, algorithms do not remove human bias. They encode and amplify it. Now, let's explore the algorithmic fairness, one of the issues AI users and practitioners they're talking about. Fairness is not just a moral issue, a moral concept, but a measurable properly in data sciences. So the most common legal rule of fairness in employment is the 80% rule. This 80% rule is also called as 4/5 rule. It states that if the selection rate for one group is less than 80% of the rate for the group with the highest selection, then it indicates something very potentially causing concern. Consider an example. In a company of 500 eligible employees, 250 are men and 250 are women. 50 promotions are available. 35 men are promoted, a 14% rate, and 15 women are promoted at a rate of 6%. 6 divided by 14 equals 43%, well below the 80% threshold. Even if we control for performance ratings, the gap persists. This demonstrates both direct and indirect discrimination. Computer scientists have proposed multiple definitions of fairness. Demographic parity means equal outcomes across groups. Equalized odds means equal true and false positive rates. Predictive parity means equal accuracy across groups. But according to the impossibility theorem, given by Kleinberg and Raghavan, no system can satisfy all these fairness definitions because they are conflicting and oxymoronic at times. Therefore, every organization must decide which fairness definition aligns best with its legal context, looking at the values and the goals. As Selbust and colleagues argued, fairness is not purely theoretical. It is a social and contextual judgment. There is no universal formula, only uh, uh, could be called as the transparent and maybe called as highly reasoned. You have to find out your own way. Now, let's discuss the explainability. In 2021, an Indian employee named Priya was denied a promotion because an algorithm gave her a score of 60 out of 10 when the promotion cutoff was 7. When she asked for an explanation, the company said that it was a neural network and could not be explained. Machine has done it, and machine is a fair. She took the legal measures and won. The court ruled that employees have a right to understand the decisions and that affect their careers and their growth trajectory. So explainability is now embedded in law. The European Union's GDPR grants individuals the right to obtain meaningful information about algorithmic logic. And India's DPDP, Digital Personal Data Protection Act, requires similar disclosure. The states in US and many other countries are developing similar regulations. There are two broad ways to achieve explainability. The first is to use interpretable models such as decision trees or linear regression that clearly shows the cause and effect. For example, if burnout score exceeds 7, the risk increases by 35%. If years in the role exceeds 4, the risk increases by 15% and so on. Each rule can be traced and understood. The linear models use coefficients that show exactly how much weight each factor carries. The second approach is to use post hoc explanation methods for complex models. And one of them is SHAP, SHAP, that is the Shapley's additive explanations based on the Shapley's values. Values based on game theory measures the contribution of each feature to the prediction. Then the other is LIME, that is local interpretable model agnostic explanations. Approximates a complex model with a simple local model. The counterfactual explanations show that what would mean to change for a different result. For instance, if performance increased from 3.8 to 4.2 and two new training modules were completed, the promotion probability, will this promotion probability rise from 42 to 78%? You have to look at it. The critical skills to communicate the same evidence to different audiences, that varies. For employees, the explanation should emphasize well-being and growth. For managers, It should present probabilities and actions. For auditors, it should show the technical specifications, metrics, fairness audits, and documentation. The same facts, three different languages, that what has been shown. Now, the other issue is of privacy. On August 11, 2023, India enacted the Digital Personal Data Protection Act with the penalties up to 250 crore rupees for violations. Similar laws exist worldwide. Privacy is not only a legal matter, but a foundation of trust. When organizations monitor employees excessively, the trust erodes rapidly. Key privacy principles include purpose limitation, collecting data only for legitimate and declared purposes; data minimization, collecting only what is necessary; and storage limitation, retaining data only as long as required. Consent must be explicit, it must be informed and voluntary. And technically, we can protect data privacy through aggregation reporting, group level statistics rather than individual level data, so individuals can't be identified. A privacy audit should include a complete data inventory, risk assessment, looking at the compliance part of it, mapping gap remediation, and ongoing monitoring. Every HR data set should have clear ownership, retention schedules, and consent tracking. And after privacy, let's look at the governance part. The ethical AI requires a living system that continuously prevents, detects, and responds to risks. The prevention means designing fairness, ex explainability, and privacy from the start. Detection means continuous monitoring through dashboards and show promotion rates, pay equity, and demographic disparities. Response means acting quickly when bias or privacy issues are found, freezing decisions, investigating causes, and implementing fixes. A strong governance structure includes an AI ethics committee with HR, legal, technology, and employee representatives. It maintains documentation such as model cards, data set, data sheets, and algorithmic impact. The training program should be mandatory for HR professionals, data scientists, managers, and executives to build literacy and accountability. Implementation follows four phases. Assess all AI systems in HR and identify risks. Design fairness, explainability, and privacy framework. Implement changes and validate results. Sustain through ongoing reviews and audits. Monthly dashboards, quarterly reviews, and annual external audit ensure continuous improvement. Before concluding, reflect on your organization's readiness. Can you define fairness test? It monitors, it explains what? Do you protect privacy by design and document compliance? If not, begin now. Even small improvements compound into large scale ethical progress. Fairness is a journey, not a destination. Social norms and laws evolve, so fairness must be continuously reinterpreted. Progress matters more than perfection. Perfect fairness or privacy may be impossible, but every incremental step protects real people and advances justice. We are the change agents. Over the next decade, AI will make more career decisions than the human managers. The frameworks you design and the ethics you practice will determine whether these systems perpetuate inequality or create opportunity. This responsibility is immense and it is also a privilege. Let's summarize. AI in HR delivers efficiency but also risk. Multiple fairness definitions exist and one must be choosing deliberately. Explainability is a right and a regulatory necessity. Privacy builds trust and ensures compliance. Governance must be operational and it should be continuous. For deeper understanding, consult the foundational works such as the fairness and machine learning by uh, Barocas and Narayan. Weapons of Math Destruction by Cathy O'Neill. And there is another good reference that Algorithms of Operation by Safia Noble. Go for reviewing the risks which AI, the standards, ISO standards are talking about AI, and look at what your DPDP Act speaks about it. Now, take action. Conduct a self-assessment of your organization. Look at its fairness, its explainability, and privacy maturity. Meet with the HR, legal, and technology teams to evaluate that how these things are there in the organization and what suggestions you have to offer so that you are able to create a win-win situation for both, for HR and for AI. And this win-win situation, the loggerheads of AI and HR that could be very well broken, and this would be possible only with your very thoughtful intervention. Thank you for your time to this essential topic, and where the most people they avoid conversations about algorithmic bias and fairness, and you have chosen to to watch this video. I'm thankful to you. See you very soon uh, to talk to you about what is there in storytelling using the data. Till then, bye bye. Thank you so much.